Hello guys, my name is Ascencion Alvarado, and in this video I'll be explaining the concept of exponential growth. I'll also be using a few pre-calculus problems to show the effectiveness and application of this concept in real-world scenarios. So what is exponential growth? So exponential growth is a formula in which x or any other variant is going to be the exponent in the formula. So in this case we have a being the original amount, b being a growth factor, usually being some type of percent, and y being the final amount. And x can be any type of unit of measure, so years or anything like that. So what's interesting about them? So exponential growth formulas are cool because they can quickly change over a short period of time. They gradually increase when it first begins and then they skyrocket at the end. Compared to a linear formula, to where it gradually increases and stays at a constant pace, exponential formulas can quickly change and show big results in a short amount of time. For this same reason, we see that folding a paper over 40 times will actually be able to reach the moon, so exponentials have the power to rapidly increase at a big rate. Since we're talking about exponential growth and not decay, I find it more suitable to talk about problems where it shows people improving their funds and improving their businesses, because at the end of the day, we're just trying to improve our futures. One of the easiest ways to show how exponential functions work is by showing it money-wise.
Count it up, count it up, count it up, count it.
I don't mean it in that way, but I mean it as in specifically showing how interests work and how they can be compounded over time. So in order to show this, I'm going to teleport towards my paper now to give you an example of a compound interest problem and show you how you might use exponentials to show business growth. So to start off, we're going to write down the formula we use to calculate compound interest, which is equals to A is equals to P times 1 plus R over N times, well, to the power of N over T, N times T. So now let's go into what each of these things mean. So P is going to be the principal amount that we started with. In this case, we started off with $1,000. Now we're going to write N, which is the amount of times it's going to be compounded per year. In this case it's quarterly, so 4. And the time is going to be for 5 years. And our R is going to be the rate, which in this case is 3.50%, 3.5%. And if we turn that into a decimal, it'll equals to 0.035. So now that we have all our variables in place, now we can start plugging it into the formula. So we plug in the P for 1,000, then 1 plus the rate, which is 0.035, and that is going to be over the amount of time, so that's 4. And then the rate times the years, and then the times compounded times the year, and then we can start calculating to make things simpler. So 0.035 over 4 is equals to 0.00875. And 4 times 5 is 20. So then we add 1 plus 0.00875, which will equal to 1.00875. So now what is equals to A? So now we can plug in 1,000 times into this calculator. Let me see. And that's equals to $1,190.34. So that is going to be our answer. But of course we're trying to find it into dollars, so we just have to put dollars. And that is going to be the amount of money she got after her 5 years of compounding quarterly for her interest.
Now look, all of them pitiful, and all of a sudden I'm so good at math. Count it up, count it up, count it up, count it.
Although $200 doesn't sound much for a span of 5 years, she made that money from only holding money in an account. And that was only with $1,000. You can imagine with big investors investing millions and even billions of dollars into bank accounts that they make much more, possibly into the thousands and millions of dollars from just holding these. So from here you can see that exponential functions really do come into play when investing, as they can make you plenty of money over the span of a couple years. Although they may take time to grow, exponential functions quickly start growing and rapidly increasing to where the more you hold on to it, the more money it's going to start making. Special shout out for all the sources used during this presentation.